Hello, people. Hello, people. Very good morning, good afternoon, good night. Today we are with Catalina Gonzalez Mancilla. We are from the New Granada Military University for the subject of power electronics, and we are going to present a beautiful presentation what the smart power grids consist of. We hope you enjoy it.
Okay, in this video, we will discuss the paper Smart Grid, the future of the electric energy system, which presents the definition of a smart energy grid, conventional energy systems, the future of smart energy grids, and finally, the challenge to achieve a comprehensive smart grid. Then my colleague, Juan Diego, will talk about the different topics in the presentation.
Thank you, Kata. The topics. The most important topics that we conclude from the PDF that my college showed previously were the introduction. The first one is in the introduction we will find the definition and how power smart grids are presented in the PDF. The second is the conventional electric energy system, which aims to understand how current power sources work and how they not only affect the power of power plants but also the environment due to their pollutants. The third is the future smart electric energy system. It is based on how the new renewable energy are visualized and how the power smart grids contribute to generate less cost and less polluting agents with the environment. And finally, the fourth is the challenge to achieving a compressive smart grid. It is about all the challenge with which power smart grids can help the planet as well as companies that have high power and performance services. We're going to explain them one by one. First one is the introduction. To understand what smart grids are, the PDF provides that it is based on three dominant factors are impacting the future electric systems in the world. One of them is government policies, the second is efficiency needs of the consumer, and the third is the introduction of new intelligent computer and hardware technologies. Then what is visualized with the power smart grids is to generate a profitability in cost in addition to satisfying a very weight energy consuming in the cities. Therefore, it is about generating an impact so that these new intelligent power networks are flexible, projective, interactive, optimist, secure, and self-healing.
The second topic, the conventional electric energy system. Traditionally, the system is broken into mostly insulated components: generation, transmission, substation, distribution, and the consumer. As can be seen the image, the first one represents the conventional energy, which are understood as those that are found in a limited way in nature and are usually divided into categories. The first of them is the combustion and fossils, and the second is nuclear. The second image is the transmission generation, which is the part of the country infrastructure, lines, towers, substations, and others that interconnects producers and consumers of electricity and allows the existence of an electricity market. And finally, the isolated components are observed. An example of them are the solar panels. The characteristic of system: one, centralized source of power generation. Two, unidirectional flow of energy from the source to the customers. Three, passive participation by the consumers. Consumers' knowledge of electric engineering use is limited to a monthly bill will be received after the fact and the end of the month. Four, real-time monitoring and control is mainly limited to generate and transmission and only at some utility does it extend to distribution systems. And finally, the system is not flexible so that it's difficult to inject electricity from alternative source at any point along the grid or the efficiently and sustainably manage new service desired by the user of electricity.
Well, for the third topic is the future smart electric energy system. The following parameters are established that seek to relate everything that power smart grids can bring to the future. The system or the power smart grid is represented in the following schematic found at the bottom of the screen. The key requirements of the system will address the following transformational functionalities. One of them is allow for the integration of renewable energy resource to address global climate change. Allow for active customer participation to enable for better energy conservation. Allow for cyber secure communication systems to address system safety. Allow for better utilization of existing assets to address long-term sustainability. Allow for optimized energy flow to reduce loss and lower the cost of energy. And the last one, allow for the integration of electric vehicles to reduce dependence on hydrocarbon fuels, for the integration of communication and control across the energy system to promote interoperability and open systems, and to increase safety and operational flexibility.
As my colleague has been saying, the smart grid energy are the future. We'll be see how they can be implemented at the system. A challenge to achieve.
And we have a problem so with network and let's talk about with Kata.
2 hours later.
As my colleague has been saying, the smart grid energy are the future. We'll be see how they can be implemented. Challenge to achieving a comprehensive smart grid. A primary object of the smart grid is to improve our capacity to use more but cheaper electricity to power the improvements in the standard of living of all people on planet Earth. However, the transition must be cost effective or we will never get there from here. The tracking of key performance metrics that continuously and automatically score improvements generated by the smart grid will be required if the effort is sustainable over the 20 to 30 years that will be required for a full conversion to a comprehensive smart grid in any country.
Okay, thank you, Kata. Finishing with the topics of the PDF, the topic of power smart grids is related to the topics in power electronics, where DC-DC converters, this one, are used for future intelligent power plants since DC signals are better for consuming issues. Although they are a bit more expensive. Voltage regulators also use whether they are serial or parallel connections. Maybe can use a regulator buck or a regulator bust or regulator buck bust, depending on where for power smart grids, whichever works best.
Thanks for you visiting us. We hope you like and give us your support.
And we appreciate that you share it and subscribe it and like it. Apart from learning a lot forever, knowledge is power. Thank you.
Thank you.